So this is lesson 7.3a, college trigonometry, and this is the law of cosines. And one of the things I want to do is look back just real quickly. Back in 7.1 on page 276, bottom of the page, it says data required for solving oblique triangles. In 7.1 we went over case number 1. 7.1 was the law of sines, and it had to do with side angle angle or angle side angle. And those are the two options that we did in section 7.1. That was case 1. In 7.2 we went over case 2, which starts on page 288. And case 2 had to do with side angle. And that was where we had the ambiguous case of the law of sines, where sometimes it worked and sometimes it didn't, depending on different things that happened. So side angle is case 2, where you have an option of 0, 1, or 2 triangles that may exist. Well, now we're in 7.3. And if you notice on, let's see, where is it? Bottom of page 294, it says solving side angle side and side triangles, cases 3 and 4. So if you look back on page 276, where it gives you our 4 cases, case 1 was 7.1, case 2 was 7.2, cases 3 and 4 are what we're going to cover in section 7.3. Case 3 says 2 sides and the angle included between the 2 sides are known. That's side angle side. Case 4 we're going to look at where you have 3 sides that are known, and that is going to be side. So that's just giving you 7.1, 2, and 3 that have to do with those 4 different cases that they give us in the beginning of 7.1. So that's where we're starting today, is 7.3, the law of cosines. And in blue, top of page 293, triangle side length restriction. If any triangle, or in any triangle, the sum of the lengths of any 2 sides must be greater than the length of the remaining side. Okay, so did you get that? If you add up 2 sides, the lengths must be greater than the length of the remaining side, or you will not get a triangle. You'll get figure 11, where no triangle is formed, because we took 2 sides, one side is 3, one side is 4, we added them up, we did not get a number bigger than C, which is 10, so it does not even form a triangle. So just something to be aware of when you're doing these. So how do you determine whether or not you use the law of cosines or the law of sines? Well, you will use the law of cosines when you are given side angle side or side cases. Those are the 2 cases that you will use when you are trying to find the lengths, and that's when you'll use the law of cosines. So if you look in the middle of page 294, they give us the law of cosines. And there it is. So notice what we've got there. When we're looking for A, let's say the length of A, we're going to take B and C minus 2B and C cosine of A. Again, what we're looking for. It kind of makes it easier to memorize these because the cosine will always be the angle of the line that you're looking for. Okay, so notice that. And notice also that, whoa, I need an eraser, not a pen. Notice also this right here. We have b squared, and here we don't have any b at all. So we've got a squared plus c squared minus 2ac cosine of b. So again, the length, we don't have any lengths that are b or anything that has to do with b until there. So they're complete extremes from each other. One's the line, one's the angle, and then a squared plus c squared minus 2ac. And these are all the same. Okay, so it's all the same idea. So if you learn this one, the other 2 you pretty much know, so not too bad. So just some basic theory before we get going here on 7.3. So pretty much the whole 7.3a is just kind of getting you set up for it. There is a note, middle of page 294. If we let c equal 90 degree in the third form of the law of cosines, that third form being side angle side, then cosine of c equals cosine of 90, which is 0, and the formula becomes c squared equals a squared plus b squared, which is the Pythagorean theorem. The Pythagorean theorem is a special case of the law of cosines, because notice, if this is a 90-degree angle, what is the cosine of a 90-degree angle? 0. So 0 times c times a times 2, this all would go away, right? If the cosine of b is 0, because 0 times everything else. Same thing, if this is 90, cosine of 90 is 0, so 0 times all of that. So all of these would disappear when we have a 90-degree angle, because the cosine of a 90-degree angle is 0. 0 times anything is 0, so those things disappear, leaving us with the Pythagorean theorem. So kind of interesting that that's a part of it. Alright, so that's it for 7.3a. We'll do some examples in 7.3b and possibly c.